Good morning, everyone. My name is Bob Schmidt. I'm a program manager on the App Fabric team at Microsoft. It's great to be here today on behalf of my team, who's back in Redmond working hard, putting the finishing touches on the App Fabric June CTP, which, as the name implies, is coming out soon, next month. It'll be in your hands. Hopefully you've been to some sessions this week that talked about other aspects of App Fabric. If you're interested in building highly scalable and available applications on App Fabric, you're in the right spot. Before we get into the content, let me just get a quick show of hands of who's been to the session that Jürgen and Karan gave yesterday, an overview of application development on App Fabric. Anyone been to that? Okay, a couple people. Great. I'm going to start this session with an overview of application development on App Fabric, just to kind of give you the big picture and the lay of the land. Then we're going to get into some of the key choices and the trade-offs that you have when you're building applications and services that need to scale and have high availability. Some of these are going to be techniques that you're familiar with, that are going to carry forward from the existing ways that you're using today of building applications and services. And we're also going to talk about some new choices that you have as well. In particular, we're going to talk about what we're calling stateful services. Jürgen mentioned this yesterday, kind of left a dangling reference. So we're going to kind of complete the story in this session, talk about this new capability and where you might use it. OK, some of you may have seen this slide in other sessions. This is the big picture of what App Fabric is. App Fabric is the next generation middleware platform from Microsoft. It's a platform targeted both at cloud and server environments. So for some of these services, we're leading with the cloud. For others, we've had offerings on the server. So the cache is an example where it shipped and was available in a premise offering. That's most recently come out and now is available as a cloud offering. Other services, such as the service bus and access control, have been out there offered as cloud services for a while now. Integration is a space where we're making some investments in the near future in the cloud space. We have a session later today that's going to talk a little about those futures and provide you a chance to give us some feedback. So if you're particularly interested in integration, I encourage you to attend that session. This session is focused on the box there called custom code. So how do you run workflows, and services, and compositions of various components up in the cloud, where we have a host that we're delivering as part of the June CTP. So this is really something new, a new way for you to go ahead and host workflows and services and other types of applications up in the cloud. So that's kind of that middle tier that is shown in the picture there in the middle on top of the App Fabric container, which is our runtime infrastructure internally that we're using to run these applications. We'll talk a little bit about the container in this session. But the point of the platform is that it embraces all of the tiers. Right? We've got a web tier, obviously, where you're running ASP applications and possibly services. You've got your middle tier. And then, of course, you've got your data tier, where you've got either SQL Server, SQL Azure, or some of the other Azure storage components that are in play. And so we're trying to build a platform that's got two pieces shown there on the left side of the slide, a development experience in Visual Studio that lets you build and compose and deploy applications instead of as a set of piecemeal parts, as a single entity. You describe those applications using our composition model, a very simple way of just telling us what's in your application and how the different parts are related. And then you can go up to the portal, what we're calling the App Fabric Application Manager, obtain an account, deploy your applications, and go manage and run them in the cloud. So you can get out of the business, if you wish to, of running these things in a premise environment. Now, as I said, our offering here is first in the cloud. This service for running custom code and custom applications in the cloud will be available in CTP form next month. This is a platform we're also bringing back into the server environment. Timeline is TBD, but one of the key value props here is around symmetry, so that your skills transfer as you're writing applications. You don't have to think specially about the cloud or about premise. Then, of course, the applications themselves gain a measure of portability as well. So with that, let me talk a little more in detail about the different parts of the value prop here, just so you're very clear on when you might choose to use App Fabric. The first point is really just a point about how easy it's going to be to develop applications. Obviously, you want to continue to build applications in Visual Studio using the component technologies that you're already proficient in. So ASP.NET and WCF and WF, as well as just custom code, are all things that we embrace with the App Fabric platform. And of course, we're also releasing a set of what you might call infrastructure services or utility services that hopefully lower the barriers to building real enterprise-grade applications using our platform. And so by this, I mean we have the service bus, we have the access control service, we have the caching service, we have integration services coming out. And we're continuing to build and enhance the capabilities of those infrastructure services based on your feedback. Second point is all about TCO, and in some sense, this is really about the economics of the cloud. Today, if you're building and running WCF services or workflows, you're either crafting a custom host or using some kind of host that's been devised to run on the Windows Server platform. And here we're taking this idea of hosting workflows and services and applications and saying you can just run them in the cloud. So if you wish to, you can go ahead and get out of the business of managing the infrastructure that's needed to run those and scale those and make those highly available. Push that problem over to us, and you just develop your applications in Visual Studio, publish them up to our cloud service. Now, part of the value here is that you do get to manage and deploy your application as a single entity. Today, it's probably the case that you're dealing with your web assets one way and deploying and managing and troubleshooting them. And you've got various middle tier assets. Of course, you've got your data tier assets as well. And there's a lot of different moving parts, and frankly, you often have to treat them like that. Different parts, you're kind of cobbling together, troubleshooting stories, et cetera, and monitoring. And we're trying to make a much more cohesive offering so you can deploy your application as a single logical entity and then get nice troubleshooting, nice monitoring in an end-to-end fashion. Now, part of the value prop here around cost of ownership is, in fact, in that container that I mentioned a minute ago, which is going to let us run applications and services at very high density. And that's just going to give us cost efficiency. So we're running a lot of different applications and services in the cloud. Within this offering, we can do that at high density. We can pass some of that savings along back to you as we're optimizing for resource usage across a set of applications. Now, the third value prop is really all about scalability and high availability. Often these are very desirable things to have in the applications and services you build. And again, very often it's hard to achieve them, right, or costly to achieve them. And so we have some infrastructure, again, inside that container, our runtime that's running up in the cloud running these services, that has some interesting capabilities around load balancing and partitioning, automatic failover, and state management. We're going to talk about some of these a little bit later in this talk. And we're kind of opening this up and making it a little more accessible to you in the programming model so you can tap into these capabilities and write applications and services that benefit from them. I already talked a little bit about the symmetry value prop. This is something that's a very core design principle for us as we're building our platform, our programming models, our tooling. We are building it with this goal in mind, that you have applications that you're building, and the choice needs to be yours about where you run them. Maybe even parts of them need to run in the cloud, parts need to run on-premise, or a decision about where the entire app needs to run needs to be in your hands, and you need to not make that decision too early. Therefore, you need a platform that gives you this flexibility that lets you build applications in a way that they can run in this symmetric fashion. Okay, just to get a little more concrete about what's in the box in the June CTP. So this is CTP 1. It's a first release of this new cloud service, as well as the developer tools in Visual Studio. And for this first release, we're trying to embrace the component technologies that you're probably using today and let you build the applications using these technologies. So ASP.NET, WCF, WF, as well as custom code. We have extensibility in the framework, as you might imagine, in the App Fabric framework, so that you can go ahead and build custom services using code if you wish to. As well, you have first-class integration of what I might call the platform infrastructure and storage services. So in your applications, in addition to these component technologies that allow you to host user code, you may also be using some of the infrastructure services that are up there running in the cloud, such as the cache, the service bus, access control, and of course the various Azure storage options as well. And so that's kind of the lay of the land of what you're going to get in the box. You go ahead and you build your application using these, again, and also custom code if you wish to use our extensibility. And then you can build and run applications. So let's go ahead and switch over to Visual Studio. I'm going to give you a quick demo just to give you a flavor of the developer tools. Okay, here we are in Visual Studio. I've installed very recent bits just from a day or two ago. We'll see how they perform. I'm going to go ahead and create a new project. And the first thing you're going to notice is that we have a new category of projects, not surprisingly, called App Fabric. And there's a few different templates in here. So the first one is just an empty application. That's the one I'm going to use here. There's a couple of other templates in here, and these are meant to just sort of give you jump starts into common application patterns. So maybe you've got an ASP.NET web app with a cache. We've just got a template that lets you get started a little quicker. Some of the wiring's already taken care of for you. We're going to go ahead and create an application, just an empty application. And what you're going to see is that a new solution is created, a new project is created in Visual Studio representing the application. So as I mentioned, what we're trying to do here is give you an application authoring experience that lets you author an entire application across tiers and then package and deploy that thing as a single unit. So in this case, I'm just going to build a very simple application. Here's my design view for the application. I'm going to go ahead and add a new element to my application. I'm going to add a stateless WCF service. We're going to talk a little bit later about the distinction between stateless and stateful. Stateless is kind of what you know and love today. I'm going to go ahead and add an instance of that to my project. And really what's happened here is just added a project, which is just the standard WCF service project, right? So I have the very same template that I'm used to, service contract and the service implementation with the typical get data starting point just as I author my service. So I'm going to go ahead and run this thing locally. So I haven't done anything here except add a new project type and go ahead and compile and run this thing. So very, very friction-free way of getting started. What this is going to do is it's going to compile the application, obviously. It's going to package it up into this App Fabric packaging format. And in this case, we just have one component in our application. But if we had several, 5, 10, 15 components, they would all get packaged up into this packaging format. That will get sent up to our management endpoint. And in this case, I'm just doing I'm running this in a emulated environment locally on top of the Azure App Fabric. We have the App Fabric emulation environment running. And so I've gone ahead and deployed the application. I can see what's happened in my output, where we see some output saying that the emulation environment was started. We provisioned the application and uploaded it and deployed it, and now it should be ready to run. We should get a URL shortly of the published address. So the system is deploying this into our host container running inside the local emulated environment, giving it a published address on the local host so I can go ahead and access it. All right, let's see if that's going to come up. All right, we'll give it just a second here. Yes, I've got a question.
So, this project type is available in Visual Studio out of the box, or do you have to install some tools to get?
The question was, where do I get this new project type? I installed the developer tools, which will be a part of the SDK that's coming out in the June CTP. So there's basically two pieces: the SDK that you would install, which will install the development environment here, or the add-on to Visual Studio. And then the other piece is the part running up in the cloud, the actual portal endpoint where you're going to get an account and then go ahead and publish your applications to it. Sorry, what was the question? Yeah, the question is, can you build and install on the local App Fabric? You can build and run against the local emulated environment, which is built on the Dev Fabric. This is separate from the Azure server offering, right? So right now, those are not in sync in the sense of being able to run the applications you build using these developer tools on that. But that's exactly the vision, that you would have a cloud versus server choice at some point in the future. Today, your choices are going to be to develop against the local emulated environment and then run it in the cloud. OK, I'm missing a published URL. So I'm going to go ahead and continue. OK, so what we saw mostly in Visual Studio there was how easy it is to get started. All I did was create a new project of that App Fabric type, create a WCF service inside it, compile it, run it, and that just deployed it on the local environment. The piece we didn't see was just the published address, which I was waiting for, and that would let me just hit it with the test client. So that would just show you that it's like no other or any other WCF service. Again, a very simple way for you to get started, not a lot of new stuff to learn to get started with App Fabric. Now, if we take a step back, and think about application development in a little bigger sense. Very often we start with kind of what we saw there with the service, which is the functional requirements, right? What does the service interface look like? What is the data coming into and out of my service operations? Or if I'm building UI, what does the UI look like? What does my page flow look like? All the functional requirements. as you all know, once you get through the functional requirements, there's a very long list of other things you need to start to think about as you go ahead and design your application. Right? So all the non-functional requirements, including some of which are listed here. Performance, so the latency of certain operations is very critical in some applications. Scalability, obviously. What kind of scale profile does my application have? Can I scale it up? Can I scale it elastically up and down? How many nines of availability do I need? Data consistency, et cetera, et cetera. So we could talk all day and probably through the night about how to achieve all of these in the applications that you're building. The point I want to make here is that you really need an application platform that's going to let you make different trade-offs and choices for different applications. Right? What you don't want is sort of a one-size-fits-all type of approach that's going to say this is how you build an application, or that gives you a very narrow sort of a sandbox to play in. So we're trying to aim very wide, give you a lot of choice, a lot of freedom, a lot of levers, if you will, to let you make the trade-offs about how to achieve these non-functional requirements or design goals in your application. So one key aspect, undoubtedly, of application development is state management. This is something that kind of cuts across a lot of these areas. This is what we're going to key on for the next part of the talk, and look at different ways of managing state in App Fabric applications. Okay, so at a very high level, what are applications? Well, they're a couple of things. They're state, and their logic or behavior that manipulates that state. Very, very 10,000-foot view of an application. But to be honest, this is usually one of the very key starting points you have when you're designing an application. Right? Where is the state in my application going to live? How many different kinds of state do I have? If I think about just a very simple application, let's just a generic commerce application that many of us use every day on the web, there's lots of different types of data inside that application. You might have product catalog data that's very large and kind of static in nature. You've got inventory data, which is sort of real time because it's getting updated to reflect the availability of the products that are in that catalog. You've got transaction data, which obviously is representing the transactions that occur between buyers and sellers. You might have shopping cart data that's capturing the current shopping carts of the buyers on the system. You may have other forms of session data that's tracking user behavior and letting you customize your UI experience. So even in a fairly simple app, and that's just almost a piece of that kind of an app, you have a lot of different kinds of state. And so you need to think about very carefully the different places you might store that state and what that means in terms of the latency for your application or different parts of your application, the scalability, et cetera. And I've just listed a couple of the different factors that you need to consider when you think about where the state in your application lives. So with App Fabric, you have a lot of choices out of the box for where to place that state, starting with the traditional SQL and other forms of Azure storage. So those are first-class places to put state. Caching is another key capability that's now available in the cloud, and so it's available for you within App Fabric to use for caching state, for pulling it closer to the logic in your middle tier. Service Bus is another example for sort of messaging-oriented state that you can now use as a cloud service. And there's a new one called Stateful Services, which we're going to talk about in just a little bit, which is now a native part of the App Fabric platform, which is yet another choice that you have that may yield benefits for certain types of applications. So before we talk about stateful services, let's talk about sort of the tried and true ways of scaling applications. And probably the most popular could correctly be termed sort of stateless application design. And the basic idea here is that you want to make as many components and as many tiers of your application, specifically your middle tier, as stateless as possible, or fully stateless if possible. And the basic idea is a very simple one. If you have middle tier logic inside a WCF service or some other component, and that, in fact, is entirely just behavior or logic and has no state, then you can go ahead and clone that component any number of times in order to achieve scalability. So if I have 5 copies of my service instances running today, and I need to scale up, I can go to 10, I can go to 20 just by copying that, and I don't really need to worry so much about state because it's not a part of my component. And part of this is that the clones are fungible. I can handle any inbound request with any clone, and that's what's giving me this sort of high availability for free as well. So I have a lot of different redundancy options there as I think about how to handle failures in that middle tier. Now, it's true that this provides scalability and high availability, but it's really providing those things for the component or the tier. We still need to think about the whole application, and in reality, the application state hasn't disappeared. In fact, the choice of making our middle tier stateless has meant that we've pushed that state somewhere. And really what this gets down to is that it's pushing it away from the logic that's actually manipulating it. So there's a tension here between achieving statelessness and trying to bring together the state and the logic that's manipulating it. And so if you're pushing state into a database or a cache or some shared resource, you're inevitably introducing some kind of contention for that resource. And so you need to think carefully about the access patterns for that shared resource. And finally, you need to think about some special cases such as sessions where really the whole point is to have some state readily available at hand because you're servicing a set of requests that may be coming in very short order that are tied together precisely by that shared state, by that session state. And so the goal of statelessness is kind of a very worthy one. It's an application pattern that's sort of tried and true, and there have been ways devised, of course, to get around some of these issues of session state through things like sticky sessions, etc. And here's a diagram that just shows what I've described. It's a nice application pattern where you've got clients hitting a load balancer behind which you have your presentation tier running. Of course, you do need to, again, think about the problems associated with session state management and what you need there in terms of session state availability. And then you might have business logic services likewise running behind a load balancer. But again, you need to think about things like connection pooling. If you're talking to a database, you can't just scale that business logic tier infinitely unless you pay very careful attention to how you're doing your connection pooling and connecting back to that database. So a different way of saying that is that once you have a data source such as a database, it does become a source of contention as you have a lot of different middle tier clients trying to access it. So one very popular evolution of this simple design pattern is to add a cache into the equation. And adding a cache does a couple of nice things. First, it brings the data closer to the logic that's operating on it. So if I have a middle tier component that is able to rely on a cache to obtain some or all of its data, that's a shorter distance to travel typically than going back to a primary data source in a line of business application or in a database. And so latency is typically improved. And there's a second benefit here, which is that we're reducing contention on that shared resource. If I have clients or services either running in the middle tier, then they're all making use of the cache, which means they're making less use of that database. And I'm reducing the contention on that database, and I'm eliminating it as a scalability bottleneck or reducing the threshold or increasing the threshold at which it will become an issue for scalability. Now, once I use a cache, I do need to carefully consider data consistency requirements. The cache itself is going to have, obviously, different sorts of semantics associated with updates than a database, right? It's going to not have transactions, for example. And I need to think about all the different pathways in my application through which writes and reads are occurring so that I have very tight control, or at least I have a very good understanding and a very explicit design for how updates are happening and what kind of consistency I have in the different parts of my application. So a couple of interesting observations about the cache. And the first is that if you're looking at the App Fabric cache, internally, it's using a technique called partitioning in order to scale. We want that cache to be able to grow, to handle any size data set that we might want to be caching. And in many scenarios, that's going to be larger than what I can put on one machine. So the cache internally needs to bring to bear the resources of several machines as it's offering sort of a single unified view of a set of data items. And internally, what it needs to do is partition that responsibility among a set of nodes so that different nodes are responsible for different data items. And this is just an internal technique to the cache, but it shows you a little bit about how it scales. The cache can also use replication internally to achieve high availability. So if I don't have any copies of any particular data item, then if a node dies or becomes unavailable, then I'm out of luck and that data is gone. And if the cache is being used purely as a cache in the traditional sense, that might be okay in the sense that it's volatile. I can reconstruct it from a primary data source if I need to. But increasingly, it's interesting to think about the cache in some cases as a primary storage location for data. And to do that, you really need this high availability. You need to turn on this replication capability. And so what this kind of points to, I think, is a broader application trend or application development trend toward bringing some kinds of data out from behind the SQL relational interfaces where they've been for much of the past decade and holding more state in memory and not necessarily having it behind a relational abstraction. You see this even in the Azure environment where you've got sort of this now interesting choice between when to use SQL Azure and when to use tables and blobs. So there's more choice, there's more happening in memory, and we're kind of riding that wave and offering stateful services, which we're going to talk about next. This is just a quick depiction of what you heard me talk about, where the business logic is accessing a cache, reducing contention on the database, and internally the cache is using a set of nodes, right, to hold the data that you've given it, and it's doing that by partitioning responsibility for different data sets across the different nodes. Okay, let's talk about stateful services. The basic idea behind stateful services is a very, very, very simple one. And that is to take sort of the logic of why we would cache something and take it one step further and say, look, let's just co-locate the state and the logic that manipulates that state. We're going to use the same techniques that we just talked about for the cache, or at least what the cache is using internally. We're going to partition this thing in order to scale it. So once you've said that I need to manage some amount of state, if that can't all fit on one machine, either today or in the future, as you expect your application to scale, we're going to need to use partitioning. We're going to need to a way to divide up the state in a uniform and deterministic way so that the different parts of your application state can be handled on different nodes. We're also going to need routing logic that lets incoming requests get routed to the right node depending on what piece of the state space they're accessing. Not surprisingly, we're going to use replication in order to achieve high availability. What this means is that we're going to keep redundant copies of our state within the middle tier, and that's going to let us do automatic failover when a node fails. So if a node fails, we need to automatically route requests that were intended for that partition onto its secondary, and the clients of this system really are none the wiser. They don't see any change in behavior. Now, not surprisingly, this capability is built on the same infrastructure that we're using inside the App Fabric cache. What we're doing here is really just kind of opening this up, making it available to WCF developers and other developers who wish to tap into these powerful features and provide state management in their applications through ways other than caching. So here's the diagram that kind of paints the picture for you of what I just described. We have clients, of course, still hitting a presentation layer that's behind a load balancer. The presentation tier is accessing my middle tier services, but it's going through a router to do that. I'm using that term loosely just to describe the sort of gateway that exists for request routing within our App Fabric infrastructure. This router is responsible for looking at inbound requests and deciding which partition those are targeting and forwarding the request appropriately. The business logic is partitioned. And in this case, I'm showing no database. I'm presuming here that I'm turning on high availability and keeping the state in the middle tier and actually eliminating the need for a database. Now, that's not a requirement. You can still have a database that's used as a secondary storage. You may need to use it for backup, disaster recovery, or to offload certain types of queries, or you may have a line of business application. All that's still possible. I'm just painting the picture here in the more extreme form of all your data resident in memory, which is also a possibility. Okay, so what does this look like in code? Let's go with a very simple kind of shopping cart service and do the exercise of trying to write this application a couple of different ways. The first is it's just some code that's written sort of in a classic object-oriented fashion that you might see sort of in a local programming model, right? If I have a shopping cart service, I have, well, not surprisingly, a shopping cart as a local variable. And I have some methods. This is the behavior that manipulates that state. I can add items, remove items, and obtain some kind of metadata about the shopping cart. And this is going to work if I run it in a console. But I'm out of luck if I try to scale this, right? I can't put code like this into a WCF service or any sort of a system that's running a service that's meant to scale. And the reason is that there is no copy of that local variable, right? I have a single point of failure. This object, once I instantiate it, is running somewhere in a CLR application domain inside a Windows process, inside a virtual machine. And if any of those things dies, this object, poof, goes away. And so I've lost my shopping cart. And so if I really need to build this thing to scale and be highly available, I need another way. And so again, this is just a stylized view of the kind of the stateless approach, where I remove the local variable and I say, you know what, I'm not going to store state in this component. I'm going to make this component stateless. That's going to let me scale it and make it highly available by cloning. And I'm going to store that state somewhere else. And the actual programming model isn't important. I've just kind of, again, put in a load and save method here. This could be using sessions. It could be using SQL Azure. It could be using any data storage. The point here is that it's external to the actual application logic here, right? We've externalized our state. And therefore, we go ahead and we fetch it whenever we want to operate against it. We perform some kind of manipulation of that state, and then we go ahead and save it out to that external system. And so as you can see, we've got a nice programming model in the sense that it's stateless, and I'm going to be able to create as many clones of this logic as I need to handle increasing load. But in the application logic itself, you see that we're going to incur some network latencies as we're going over to obtain our data and save it back. We also need to think about a lot of things that aren't showed in this simple code snippet. And so if I have multiple concurrent requests that are coming in accessing some state, I'm going to potentially run into conflicts when I go ahead and write. So I have to deal with sort of write conflicts and think about what I'm going to do if I try to update some data that's stale. I could think about using locking, distributed locking sort of a scheme. But the point is that there's some real coordination challenges. Right? I might have transactions available depending on my back end. I might not, especially if I'm in the cloud environment. So there's a fair amount of work, coordination work, that I need to consider very carefully when I start to think about clients in a middle tier which are accessing a data store and performing updates against it concurrently. So there's a little bit more to the stateless approach than is implied by just the simple cloning of middle tier logic. So what does stateful services give you? Well, stateful services is shown here. This is sort of a return to being able to program against a local state. And what we've done is we've added some attributes in our programming model to let you designate what state needs to be replicated. So we're trying to make this as simple as possible. There are also imperative forms of this programming model that I'll talk about a little bit more later. But for the 80% case, we want you to be able to say, I've got something like a WCF service. I want to make this thing highly scalable and available through the state management functions of App Fabric. I need to do two things in my program. I need to tell the system what state is needing to be replicated. That's the replicable attribute. And I need to tell you when replication should occur. So some methods actually manipulate state. And in this case, those are marked with the replicate on exit attribute. And other methods, such as the last method here, are read-only and therefore don't need to trigger replication because they're not actually touching any state. So in a nutshell, the programming model is that simple for getting started with stateful services. Let's go ahead and look at a demo so we can look at it in Visual Studio. OK, here we are in Visual Studio. I have a very simple stateful WCF service here that I've built. It's a calculator in the tradition of WCF demos. I have a simple calculator interface with add, subtract, multiply, and divide methods, which each take an integer. And they return a result. My result is a custom type that has the value of the calculator as it currently stands. And it's just giving us some other metadata that's going to be interesting for demo purposes. So I'm returning the ID of the server that served this request. That's going to let us see how the partitioning occurred and what kind of failover semantics we have if we can simulate a failure. And I'm also including the history. So this is just the history of the operations that you've executed against a particular calculator. So it's a very simple service. The implementation of the service is going to use these attributes that I just described. And so we have a calculator service implementing that interface. It keeps an integer, which is the current value of the calculator, and I've marked this as replicable. And so what this tells the system is that this piece of state is important to replicate. We need secondary copies of it so that if a failure occurs at our primary node, we can fail over and we can service the requests on the new primary. I have a couple other local variables which are not marked as replicable. I have the process ID. That's actually going to be a piece of state that we can reconstitute when we fail over, and it's actually going to be unique to the process that's running the code. So we don't need to replicate that. And in this case, I've made the choice to not replicate the history. Right? I could very easily make the choice to do that by adding the attribute. For now, I've left it off. In the add operation, what I've done is just what you'd expect. I take the input, add it to the current value, append to the history, and then I return the result. So that's all that's happening in the calculator service. And the only touch points you have here with the new programming model are the replicable and replicate on exit attributes, which are defined in the system fabric namespace, which is in the assembly of the same name, and that's what's shipping in the App Fabric SDK in June. So if we pop up and look at our application, we now have an application that has two moving parts. It's got a web application, which is our front end that's going to be driving the calculator. And then we've got the stateful service running in the middle tier, which is keeping the calculator values and implementing the operations against the calculators. So these two are related in the composition model through a service reference. And what this means is that the web application essentially just has a named relationship to the stateful service that's running. And so I've created a relationship between the two. I've given that the name, import one, that was just the default. And so what we've done in the composition model is just capture the fact that these two components are related, and we've given that relationship a name. And so what that means is that when I'm in my web application and I need to go obtain the reference to the calculator, right, I need the proxy object so I can go call operations on it. I'm going to call an API that we have in that system fabric namespace, and I'm going to provide the name of the relationship. So I'm saying, hey, I need the proxy for this thing I've called import one. And I'm also going to pass the partition key. Right? The partition key is going to tell our router which instance of the calculator service I'm actually trying to access. Right? The partition key is, again, something we haven't talked in detail. I'll talk you through that after we go through the demo. But the partition key is, again, essentially a piece of the address that lets you say, I'm addressing the calculator service, and I'm addressing this partition of it. One last piece of the puzzle here. Go ahead and I've defined the application using the UI, the developer tools that you saw a minute ago, and sort of depicting the different layers of the application. If I need to or want to, I can also go ahead and manipulate the definition of that application programmatically. I'm doing it here just kind of for illustrative reasons. I'm going ahead and setting my partition policy here. I could do that in UI if I wanted to. In this case, I'm just showing you how I can set up a partition policy programmatically. And what I've done here is say I have 3 partitions for my simple calculator service. In this case, I'm just creating 3 partitions with the names calc1, calc2, and calc3. And I'm also specifying a replication policy that's telling the system how many replicas to maintain. So by setting a replica count of 2, I've said I want high availability, which means I want a secondary replica of each partition to be created. And that's going to give me this ability to fail over. So that's a very quick tour of how I built the application. Basically, the moving parts are the definition itself, which includes the web app and the stateful service, this meta information about the partition policy and the replication policy, and then there's just the web app and the WCF service. WCF service written using the new replicable and replicate on exit attributes that tell us how to participate in replication. So let's take a look at the app in action. Here we have some very simple UI for choosing a calculator and then executing some operations against it. So I'm going to go ahead and, again, I have 3 partitions running here, so 3 instances of the calculator. I'm going to go ahead and just do a couple of operations against a couple of calculators, and then we'll see how the state is retained. And then we'll experiment a little bit with failover, assuming that things are behaving well. So let's see. So I've gone ahead and issued an operation against calc1. Not good. Let's try again. I'm going to go ahead and deploy this thing again. Okay, so I've rebuilt. I'm going ahead and deploying again. Again, this is going to spin up the emulation environment locally. It's going to take a minute just because I had to bring it down. It's going to go ahead and package up this application, which has a web front end. It's got a stateful service in the middle tier, so that package has gone up to our local endpoint. The calculator service has been deployed. We now see the published addresses where we can hit the different public entry points on the application.
Can you still use WCF testing from Visual Studio or Visual Services?
Question is, can I use the WCF test client? And yeah, the answer is yes. So once these things have a published URL, it's just a URL on the local host. You'll be able to point to that. And
But I mean, like taking a WCF service project and right-click and the bug start notice, it pops up like right from your developer.
yeah, we don't have that hook just right there in the developer tool right now. But yeah, we could build that. Mhm. Yes.
Calc 1, Calc 2, and Calc 3, are these three instances on the same node, or would they be on three different nodes?
The question is, are they going to be deployed on the same node? So the answer is going to come to how you've deployed, or how you've configured the environment. So you're going to specify how many different nodes you want these deployed across, and then your replica count is going to determine how many different partitions. And so we're going to spread those partitions across a set of nodes. All right, looks like we're 2 for 2, and it's faulted again. I'm going to give it one last shot. Bear with me. Okay, tell you what, I'm going to keep an eye on it. We'll go on, and we'll come back once this thing starts behaving a little better. Okay, I want to go in a little more detail on the concepts behind stateful services. We saw the simple programming model for designating state and the methods that touch state and therefore trigger replication. The third piece of the puzzle is partitioning. It is important to consider your partition policy carefully. This is going to be the way that the system divides up the state of your service. If we think about the shopping cart example, let's just sort of go with the first thought that comes to mind, which is, hey, we could choose something that's fairly simple, like every shopping cart has a username associated with it, and the partitions, we could say there are 26 partitions, and the first letter of the username is going to be the name of the partition. And what that's going to do is put all the carts for the usernames beginning with A into one partition, and all the carts for usernames whose username begins with B into a second partition, et cetera. It'll work, but you're probably going to get a pretty uneven distribution of shopping carts, right? Because your usernames are probably not evenly distributed. And so that's, again, kind of possible. But in the shopping cart scenario, probably better to go with a technique we call hash-based partitioning. So this would allow you to do something like assign unique identifiers to every shopping cart, which you're probably doing anyway. And then hashing those identifiers into a range from 1 to n, where you're going to choose n, which is the number of partitions, based on how much you want to scale this application. And then that state's going to get more evenly distributed. So I could say I want 100 partitions, and I'm assigning GUIDs to my shopping carts. Then I'm just hashing each of those IDs into an integer from 1 to 100 and sort of randomly placing them within one of those partitions. So that's going to be a better option there. Now both of these are supported in the box. And sometimes, in fact, you do want the first example, which is sort of a fixed key partitioning, as we would call it, because you do want to explicitly put certain pieces of state into the same partition, and that can be a way of doing that. The hash function is also, or the hash partitioning is also useful, again, when you want this sort of even distribution of state where the state is typically identified with some kind of GUID. Okay, so how do we get scalability? How does this partitioning actually help us in the end? And to illustrate, I'll just show kind of an example here where we've presumed here that we have a stateful service that's been partitioned. Each of the small black rectangles there is sort of meant to be a single partition. And we said, you know what, for the initial rollout of this application, we can probably handle the load on 2 machines and sort of give each of the machines responsibility for half the partitions. And so all you need to do is tell us the number of machines, basically the scale out count, and the system will go ahead and spread those partitions automatically across those available nodes. Now, as the load increases, and you decide you need to handle that with an increased amount of resource, you can say, let's increase the number of the nodes that we're using for this service from 2 up to 10. When you do that, the system will go ahead and automatically rebalance. It's going to take the partitions that are currently spread across just 2 nodes, and they're going to spread them, and the system's going to spread those across 10 nodes. So that kind of rebalancing happens automatically within the system as part of just sort of turning this dial and saying that I need to scale up and increase the amount of resource that I'm using to run this service. So that's a nice feature. In fact, the placement of partitions is even a little more nuanced than that. We can pay attention to the actual load that's being exerted by clients against individual partitions. And so we don't just have to do a very simple calculation and spread them, so there's an equal number. We can actually take hot partitions and give them their own node if they need that, or put them on a node with fewer partitions. And so we can do a pretty sophisticated amount of analysis of the load and decide what kind of placement of partitions is going to most evenly distribute that load. The other part, of course, is scaling down. So that load may have been temporary for whatever reason. Maybe the app is sort of seasonal in nature, right? More traffic at Christmas time or around some other event. Or maybe there's just a spike for some other reason, like a world event. And so the dial was turned up, and we scaled up and used 10 machines or 100 machines. And now we need to turn it back down, because now the load is decreased. And so just the inverse of what you saw a minute ago is going to happen. We're going to say to the system, we want to go down to 5 nodes. And then the system is going to automatically take care of kind of repacking or compressing those partitions back onto that smaller number of nodes. So that's how scale works in a nutshell. Let's look at availability real quick. And in fact, let's just look at one partition. It's easier to think about things in that sense. And this is going to be in play, or for all of the different partitions in parallel. We're just going to look conceptually at what happens with one. So we have one partition. If we don't create any copies or any redundant backups, then this will be a single point of failure. Right? We will have our state in only one spot. So typically what we're going to do is configure the system to have one or more backups, what we would call secondary replicas. And in this example, I've shown 2. So what that means is that you'll have your state for this partition running on a primary node. And in this case, we'll have it in backup, in duplicate, in 2 different places. So 2 different secondary replicas being maintained. And so if the machine that's hosting the primary replica fails, could be for any reason, in the CLR failure, at the process level, the virtual machine is down or inaccessible, we need to fail over to one of those secondary replicas. And that failover will happen automatically. The system will take care of detecting the failure of the primary node, the election of a new primary. So one of those secondaries will step up and become the primary. And then it will also spin up a new secondary, since to maintain the desired redundancy, we need two secondary replicas. So the system will step in and handle that. Okay, let's talk quickly about data consistency. Actually, before I do that, let's go back to the demo, since it looks like it ultimately did get deployed successfully now. Great. Okay, so this demo is going to show what I just talked about in the slides instead of doing it before. I'm just going to do it right after. We have our stateful calculator that we saw a few minutes ago that was built using the stateful service programming model that's keeping track of a current value, a history in a volatile fashion, because we're not replicating that, and a server ID. So I've issued my first request against calc1, which is the first calculator. We have 3 partitions and 3 calculators here. And you see at the bottom that I have a current value of 1, and this is being served by server 8544. Actually, the process ID is to 8544. So I can go ahead and issue some more requests against this guy. And as you can see, the value is getting updated, and the history is getting updated as well. So now I can go ahead and start up a second calculator. I'll hit calculator 2, issue some operations against that. You can see that's getting served by, I think, a different server, 8104. And so we have a couple calculators that we're using here. So what I can do is I can close the browser session, and I'll just reopen it and keep using those calculators just to show you that the state is being maintained right now in those objects that are running inside the local emulation environment. I can go back to calculator 1, right, add another 1 to it. And as you see, this history is maintained. I'm now up to a value of 5. And so I can just keep doing this all day, just keep accessing the calculator, and life is good. So what we've seen is how the state is retained and how I'm using partitioning to be able to label and identify and access each of those calculators individually. Now what I want to do, though, is show you failover. So what we can do is go into the task manager, and we can look for the Fabric worker process that is got the ID 8544. 8544. So if I scroll down, I can look at the Fabric worker process.exe processes. These are the actual processes that are housing the container, which is our runtime, inside which we're running this stateful service. And so if I go ahead and kill the process, then what I've done is I've simulated what would occur in the cloud on commodity hardware from time to time. The node goes down. The node becomes inaccessible for some reason. And so at that point, it's the job of the system to step in and detect that failure. It's detecting the failure of the node because there are heartbeat messages, et cetera, in the system, and it can detect those failures. At that point, the system's going to have to say, you know what, that node which went down was a primary partition, or the primary node for a certain number of partitions. So we need to elect new primaries. So it'll look at the pool of secondaries that are available. It'll spin up a new, or it'll assign a new primary for that partition. And then it will also create a new Fabric worker process to house a new container, because we now, again, need some redundancy that we lost when we had that node failure. So it's going to rebuild another secondary, right? So we've seen another Fabric worker process in the meantime get spun up, I think. And now, hopefully, we should be able to hit this calculator and see it continue to work, right? If the failover worked, not all the bugs are gone in the system yet, so I can't make a guarantee just yet, but let's try it out and see what happens. So if I add 2 more to Calc 1, let's see what happens. There we go. So we got the result we expected, right? We had a value of 5. We added 2 more to it, so we got a value of 7. You'll notice that the history is gone, right? Why is the history gone? Well, we forgot to mark it as replicable state, right? So when we failed over, we started with a history that was null again, and so now we're going to start adding to that again. But the failover did occur to a secondary which would preserve the calculator value. And so if I wanted to say, you know what, my application, I really do now want to go ahead and consider that history stuff that needs to fail over, all I got to do is go back into my program, put that one attribute on that local variable. So it's as easy as that to decide what needs to be replicated. And you can very easily then do a cost benefit of sort of what state deserves to be replicated and what do I consider it okay to lose. The other thing you'll note is that the server ID has changed. So this has been served by server 6252. So we indeed did fail over from one particular process into another one. OK, so let's see. Back to our discussion of data consistency. One of those other classic trade-offs that we have when we're thinking about state management, whether it's in the database or in the middle tier, is the consistency of the data. And so the replication that you saw unfold in the demo there, and I described earlier, by default in the CTP is going to be synchronous. So those inbound requests that are coming against your service, they will be held until replication completes, if you've marked the method as replicate on exit. And what this is going to ensure is that all the secondary copies are up to date, ready to go, ready to become the primary, fully on standby should a failure occur. That's a stronger level of consistency, but at a price of a little bit of latency, because that replication has to unfold as part of the client operation. Now we envision also giving you an option for asynchronous replication, and that would let you decouple the return of the client request from the actual replication. And so again, this is just going to be a dial that lets you play with that consistency and say, you know what, maybe I don't need to replicate on every method return. Right? Maybe I can schedule my replications or otherwise batch it and get more efficiency out of my replication, again, at a cost of consistency. So that if failure occurs, I may lose some amount of data, or I may have an inconsistent data set. And for some kinds of data, that's entirely valid and very realistic and reasonable. For other data sets, that's not going to be what you want. You'll want to stick with synchronous replication. The point is that you have or will have the choice. And really, this is nothing new. These are the same trade-offs that you make traditionally in the database. We're just kind of pulling them into the middle tier. And when we do that, again, we want to preserve that choice that you have. In the database, you're deciding how to maintain replicas and secondaries. You're using replication or log shipping or some other form to give you resilience in the face of disaster. And we need to use the same techniques really in the middle tier to give you that choice. Other techniques can also be borrowed and used in the middle tier as well. So in the database world, very often, again, depending on the kinds of data you're talking about, you may have a master-slave type of relationship in your database where you're routing all writes into a master and then using a set of secondaries or slaves to handle read requests and offload some of that load from the primary. And the same pattern can be true in the middle tier as well. You may very well be handling all writes on a primary, but want to spread the load of read requests across a set of machines. And so these are techniques that we're all exploring for use in the middle tier. We're going to rely on, to some extent, on your feedback as you play with this capability and tell us kind of what patterns are the most important in the middle tier for the state of your applications. Yeah, question here. Yeah, the question is, so where exactly is that state being stored in the replicas? So the replicas are essentially just like the primary. So they are instances of, in this case, that stateful service. So there is a calculator service running on a particular node. Again, today in this demo, it's in the simulated environment, but up in the cloud, it would be literally on different nodes spread across fault domains and upgrade domains in an Azure environment. So you're going to have a copy that is designated the primary running on some node, and then you're going to have secondaries, which are in all way, shape, and form replicas of that primary. So they are going to have the same data. They're going to be ready, essentially on standby. So should that primary fail, all we need to do is update an address in a routing table, right? The address is going to say, oh, you know what? This is where the primary is. If we detect that failure and we say, OK, we need to elect a new primary from the pool of secondaries, we'll do that, make that choice based on load, and we'll say, this is the new primary, update an address in the routing table, and now all requests will go to this guy. And so that's all it is. It literally is a secondary copy waiting. Yeah, another question here.
So if I have multiple copy and it happens my request comes into not the primary copy. So what happens if I update it? If they update the primary copy at first, I mean the running instance is not the primary copy. So I have multiple service instance and multiple copy updated.
Yeah, I think I follow your question. If not, let's resume afterwards. I think what you said is that, yeah, what happens if I'm not servicing the request at the primary? The answer is, right now, all of our CTP logic is, in fact, oriented around routing the request to the primary. So the router that sits in front of the service is not just a load balancer. It's not just spraying requests across a set of instances as it would for a stateless service. It has to say the partition key, which you saw in the code snippet I showed you, is essentially now a part of the addressing scheme, right? It says I have a service at a published URL, but there's also a partition key that can be used by that router to go hit the right service, right? What I described there about routing reads to secondaries is sort of an advanced case, not there in the CTP, but again, I'm putting that out there as an example of a pattern to see what kind of things we also need to enable beyond that sort of bread and butter route to primary case. If you have further kind of nuance or behind that question, happy to talk more at the end about that. Can we just hold the questions? I got a couple more slides, and we'll get to the questions at the end of the session. So just to recap kind of what you need to do to get started with stateful services, there's basically 3 ingredients, and you've seen them in the demo and in the slides here today. As a developer, what you need to do is first think about partitioning. How do I want to divide up the state of my application? Right? Do I have sort of a fixed set of keys, if you will, that I will use to enumerate and just tell the system what the partitions are and what their names are? Or do I have this sort of a hashing kind of scheme that I want to employ where I say I need this many partitions, whether it's 10 or 100 or 1,000 or 10,000, and then what I'm going to do is I'm going to hash inbound requests using a partition key that's provided by a client and sort of spread them sort of in a fairly even and random fashion across those partitions. So partitioning is one. And then the second part is what to replicate and when to replicate. And we saw the attributes that give you a very easy way in your code to designate the state and the methods that need to participate in replication. We also have imperative forms of the API. So if you don't want to use the attributes, We have a type called replicable of T, so you can create variables of this type and have a more explicit model for how you designate your state, and it gives you a little bit more access to the underlying capabilities. Likewise, on the replication initiation side, you can choose to bound your replication operations using what we're calling replication scope. If any of you have programmed against transaction scope, you'll get a feel pretty quickly for what this is like. But it gives you a way of explicitly telling us where the boundary around a replication operation should be if you don't want to use the simple form, which is the attribute on a method. There's some other advanced extensibility points here. So as needed, you can go delve into these. We'd love to get feedback from you if you do go beyond these simple cases, which we do feel are enough for the 80% case. But if you want to go ahead and do things like configure write through or write behind to secondary storage, so maybe you have your state in your middle tier, and you're using our stateful services, and you're replicating and partitioning your data, but you also need to write through to a line of business application, or you also want the data for queryability in SQL Azure. Right? Those are other patterns that we see as very common and need to enable, and we've done some work to enable those. You'll need to do a little bit of work to wire those up, but again, those are things we'd love to get some feedback on as you experiment with the CTP. Other things like around participation in memory management, our container service, as you might expect, pays pretty close attention to how the applications it's running are using memory. Certain things happen when you reach memory thresholds, and you can participate in those. And of course, you can also participate at a lower level in replication. So all the replication that we saw is happening on your behalf. But if you need to plug in at a lower level to improve some efficiencies or gain access at certain points in time during the replication algorithm, you can do that. The demos that we looked at today were WCF based, and we feel that WCF is probably the right natural choice to get started with stateful services. It's a right paradigm for building services that can run in your middle tier in this stateful fashion. But you also, again, have an extensibility point you can derive from our base class directly if you wish to, and just build custom services that directly access those or tap into those replication and partitioning features. So both are options. To finish, I want to kind of just show the big picture. We talked about stateful services at the end, but I want to back up and kind of give you the full view of App Fabric that we started with. So if you download the CTP in June, as I hope you all will, you'll have two things. You'll install the dev tools on your machine, and that will give you that Visual Studio environment for composing your application out of the different component technologies that you use today. You can then go ahead and publish that application up to the App Fabric Application Manager that's going to be up there as an offering in the Azure cloud. So you'll provision an account. You can then just go ahead and package and upload your applications or publish directly from Visual Studio. So what that's going to do is it's going to push the definition of the application as well as all the artifacts that are required to run it up into our Application Manager. Our Application Manager can then turn around and deploy those assets into the various parts of Azure. So it can go ahead and say, oh, you've got some web stuff. I'm going to put that in a web role. Oh, you've got some stateful services or stateless services. I'm going to run those on our fabric, as we're calling it, which is basically just a set of nodes that are running our container service. If you have other things that you need to provision, like a cache or SQL DAC for Azure, the App Manager will take care of those as well. So you really do get kind of deployment of an entire application in one shot. Then at runtime, there's going to be this router component that I described, which is where the published addresses are registered for all the services running in our fabric or on our container. And then you can have clients that are accessing the web assets directly, as we saw in the demo. So that's just a normal web application. Or hitting the stateful services themselves, or stateless, hitting this router as the intermediary so they can get routed to the right partition. So that's the big picture. Just in summary, I want to encourage you all to experiment with the CTP when it lands next month. We'd love to get your feedback on the simple scenarios, the more complex scenarios, basically everything that matters to you. We want to fold that into our planning for the next CTP. As I've shown you today, you can get started very, very simply by writing WCF services and other things using our application developer tools. Of course, you can fold in the use of other infrastructure services within your applications. We didn't see that today, but there's a lot of content this week about Service Bus and ACS and caching. And that will help you move beyond just building simple services and workflows to building end-to-end applications and using this as a way of deploying and managing those. Finally, I want to just put a particular call out there to help us evolve this new capability that I've described in the latter half of the talk, stateful services. Again, we've got this in the CTP for you to play with. We would love to get feedback from you about what you like, what you don't like, what you'd like to see addressed in future CTPs. So with that, let's look at the timeline real quick. Just a couple of reminders. I'm not going to talk to all the points here. This summarizes what's been released already. I've mentioned what's coming in June, the developer tools and the application manager. You can expect us to be releasing on a 2 to 3 releases a year type of cadence up into the cloud. And so again, your feedback is going to be super helpful for us as we scope and then deliver on a next CTP in the second half of the year. So with that, I want to kind of wrap up. I'll open it for questions. I want to thank you for your time and hope you have a great rest of Tech Ed and safe travels home. Thank you. Got a question over here? So could you speak up or use the mic?
Just to say, how much of this is going to be moved over to the server environment? So, if I want to build this in my private environment.
Sure. The question is how much how much of this and when will it be moved over to the server environment? Obviously, I don't have a crisp timeline to put up there. If I did, I would do that. We are going into the cloud first with this particular offering, with the application manager. We know already from talking to customers that it's very important to have an offering on server of the exact same capability, right? This is in other words, many people are saying, yes, this is the host I want to use for my WCF services, for my workflows, in fact, for my applications. I see that you're putting it in the cloud. Maybe I can use that, but maybe not. Maybe I do want it on premise. And so having a symmetric offering on server is something that we are planning, and we would love to get more feedback from you. So go through the channels that you have available to give us feedback on how important that is to you relative to cloud. And at some point in the near future, we'll have a better, crisper roadmap. Tony, do you want to add to that?
Yeah, just to add to that. So can you go back to the other picture before? Right. So the one before that even. So the App Fabric slide, go back. Go back.
You're going all the way to the.
Go back the App Fabric one.
Okay.
Right? So wherever that is. So that picture of the App Fabric platform, and right at the bottom it says, it has the picture of the cloud and the server. What we're building is this platform for both, right? The question is just about when are we going to deliver. And so right at the top there, it sort of tells you what our strategy is, right? And our strategy is release on Azure very quickly, right? Innovate there, bake it, harden it. That's going to be our sort of initial vehicle, as it says at the bottom, cloud. And just as we do for a lot of our other server products on-premise, whether it's SQL or BizTalk or Windows itself or SharePoint, every 2 to 3 years, expect a on-premise release of this exact platform, right? So we're only building one thing, right, which is that picture there. We're only building one thing, and that thing, as you see at the bottom, works on server and cloud. The only nuance is you won't get the server thing for probably around about a couple of years, right? We're saying 2 to 3 years is our server cadence. So there will be an App Fabric server. There will be all of these services up on Azure, and that's how we're going to deliver it. Now, because we're only building one thing, the approach is, get all that stuff up and baked and hardened up in the cloud, and then just suck all that goodness down and ship it as an on-premise server. Right? There aren't two things that we're building. There's one thing. And so it will be completely symmetrical between those two worlds.
So what's going to be your compatibility then, because of those already built in?
Well, in this particular area, what you're building today is, and what Bob showed, you're just building WCF services, right? And all you're going to need to do if you want to sort of leverage this infrastructure is go through those simple steps of working out what my partitioning scheme is and attribute your code to say what needs to get replicated. Done, right? Right, but on the existing App Fabric release in this particular area, you do not have the concept of a stateful service, right? But you have the concept of a service, and all the existing on-premise App Fabric release does for your services is allows you to manage them a bit better and get some monitoring information, right? It doesn't handle state at all, right? This is a completely new thing. And so to take advantage of that, you just got to do those two things to an existing WCF code-based service, and then you get all the benefit of that.
Yeah, it is also viable to continue to run something that's written in a stateless form in that form on App Fabric, right? We don't mandate that you move to
Right, that's the point. Yeah, that's a good
Great.
point. Yeah. Yeah. Well, the migration. Yeah. No, if you've got an existing WCF service and you don't want to do anything other funky stuff from a state perspective, you just want to run it on this new thing, we'll just run.
Yeah.
What do you currently have available as far as caching on premise?
Yeah.
Is that out yet, or is that TBD?
So the question was, what do we currently have available on-premise for caching? So we basically have the cache. If you go and find Windows Server App Fabric, that contains caching, right? So we have the caching on-premise today, and we actually just last month released caching in the cloud. That's sort of one of our examples where at least the capability is the same between these two worlds, and of course the App Fabric cache today is sort of not built on this sort of architecture. But as we go forward, with this new platform, that's all sort of getting rationalized together. But the capability is there on premise today as well as in Azure.
So if you have 3 or 4 or a dozen instances of that Calc 1 partition website, but they're all firing at the same time, I don't know, did you mention concurrency management? I don't know, maybe I just missed it.
Concurrency management, yeah, it's certainly not an aspect of the program model I went into here. We do have sort of a lock manager abstraction that's going to let you decide and have some freedom about how you are essentially just locking the access to the replicable state. Now, the thing that's a little simpler is that you are talking at least about concurrent access within an application domain, right? You're talking about that. It's not a distributed locking precisely because the requests have been routed to a single partition. And so you do need to think about concurrency, but it's more in terms of the .NET CLR-based locking mechanisms that you're familiar with. So we're just building around those.
I have a question based on something you'd mentioned on caching, being the state, and maybe going away from the original model that we wanted to cache as little as possible. Usually when you're dealing with data like this, you can sometimes be dealing with very large quantities of data. How do you find the balance with the change of the recommendation on caching as far as where the limits are on what's appropriate, what's not, memory usage, et cetera, because those are some of the other things that come into play with caching that need to be considered on an architecture.
Absolutely. I mean, yeah, there's obviously a laundry list of factors and concerns that are going to prevent me from saying really anything prescriptive. I can say a few things. First is that, particularly around the stateful services, we're building this so that it has extremely high scale. So it's not the size of the data set that would really be a limiting factor. If you have very large data sets, we would love for you to consider this as a way of keeping that data close to the logic that is operating on the data. It's going to come down to some analysis, right, of costs and benefits. We think you're going to get latency benefits by keeping that state very close to the logic that's accessing it. However, it's going to depend a little bit on your read-write query patterns, exactly what kind of benefits you get where. It's going to depend a little bit on how you partition your data, right? Sometimes you do need to do queries across partitions and things like that that are a little more expensive in this model, although certain things are a lot cheaper. So it's very hard to be prescriptive. I think maybe part of the answer is going to be you're going to need to see some case studies and some examples that show you very concretely not only what the levers are, but have some data behind that to say, okay, when we designed this thing this way and we got these benefits, we designed it this way and we got these benefits. Because again, it really comes down to a set of trade-offs. That long list of different application characteristics I showed you are not things that you can all achieve in isolation. You're often trading off one to get another, as you know.
So will Microsoft have some prescriptive recommendations or case studies or anything around this?
Yeah, I think it's fair to say that we will have to. Given that this is a first CTP, we don't have as much of that as we would like. And in fact, we're going to obviously be looking for partners to help us get there as we build out proof points around the platform. But yes, the short answer, again, by the time it comes to adopt this in a production sense, we're going to need to tell you very concretely what benefits you get in what kind of situations.
I was talking to the Entity Framework guys about caching in an external environment from Entity Framework web servers that would have, kind of a redundancy where we wouldn't want the cache on one box, so that they could share and update the cache if you hit a request to one machine, update it in a shared location so that it can be replicated down to another machine. And they told me to talk to you guys about potentially putting a cache like that in App Fabric. Is there anything that you've done working with Entity Framework in cache in App Fabric like that? And then as another question along similar lines, would the cache that's there support SQL dependency invalidation to hook into the SQL to let you know that those records are bad and need to be updated,
Right,
et
right.
cetera?
So there's a couple questions there. I can answer, I think, the second one first. The place to go really to get a lot of specific caching questions answered is going to be a session this afternoon where there's going to be some caching experts. But I think specifically there isn't, the cache is not being used as a front to SQL. It is a cache aside, to use kind of the accepted term, where you're responsible for adding and removing items from that cache. It's not an automatic protocol between the cache and a backend like SQL.
Okay.
Your scenario that you mentioned first, I didn't kind of fully follow. You can use the App Fabric cache within this application development environment. Right? The cache itself is going to be provisioned across a set of machines. In fact, it's running as a service right up in the Azure space. And so it's not so much running within the App Fabric application environment as it is just another cloud service that we're tapping into from within an application. Does that make sense?
Mm-hmm. So it's a place to store your cache. You still have to manage it yourself.
You need to tell, well, if you're going to provision a cache through our service, you need to tell us how much cache you want.
Mm-hmm.
And then here you're just going to configure, you're going to write some code that accesses it using the SDK. So you can represent it in the application. If you need to provision it through this application's provisioning, I think you can do that. But there's really not much beyond that that's existing here.
I'm just kind of looking to see if there's something where Entity Framework, maintains a cache. If there's some easy way to get that just moved over into the App Fabric, or if there's going to be a lot
Okay.
of custom code to manage it.
I can answer that a little bit. So the question was, it's really about when is the cache going to be more explicitly tied to the database. And because today there's really two models. There's the program against the cache, put stuff in the cache yourself as a developer, get stuff out. There is an implicit model where we have cache providers, and the cache providers today are for ASP.NET session state, so you just hook up the cache, and it's just a configuration thing, and then session state just gets automatically stored in the cache as opposed to on the local machine or in SQL. So there's sort of those two models. We are, on the roadmap is plans to sort of tie the database and the cache together so that there is sort of more of a, read through, similar to what Bob was saying around it from a stateful component perspective. There is sort of a read through mechanism to the cache, and both sort of bidirectionally. And once we have that in place, then that's where those things happen. And of course, if you sort of project that forward, ultimately you want to be able to do things at the data level and annotate your data with sort of primitives that tell you from a data model perspective what's cacheable, right? And that relationship between the database and the cache. So all of that stuff, as we think about this sort of journey and the platform as a whole, is much further out, just directionally, but that's sort of where we're headed.
Pretty straightforward question. I hear on-premise and cloud, and briefly, like the first day or two, there people were talking more about private cloud also. So when you talk on-premise, you're talking just server. You're not talking private cloud, or are you? So is this going to be available in the private cloud?
So when you see, so the question is, the way to think about this is we're only building one thing, right? That one thing is built using the cloud architecture, right? The requirements of the cloud drive you to build things in a different way. Now, because we're only building one thing, when that thing comes back to the server on premise, it will work in exactly the same way. So when I think about the bits that will sort of be plopped on servers, those look way more like it's just the cloud, but on my tin, right? And it works in exactly the same way as it works on Microsoft's tin up on Azure. So it really is the private cloud, you know, in that sense of the word. You know, the whole concept of, you know, server and install, you know, app on that server and everything sort of goes away. It goes more to the proposition of I've just got to put a ring fence around a collection of machines. That might just be one machine, but it could be 100 machines in your own data center, and it's the responsibility of this infrastructure and you as either an application developer or as an administrator to determine where things can go and what sort of levels of resilience and availability and all of those things that you need. So you'll say to your application, give me 3 nines. Right? And then the infrastructure, all of those pieces in that box there, work out how to give it you. And of course, if you've built applications using this platform, like stateful services that are, you know, we can easily just scale those, and the state moves with the service and all of those things, and the partitioning schemes, blah, 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 blah. The infrastructure can truly deliver 3 nines or 4 nines or 5 nines, and all it's got to do is spin up different, you know, different instances and so on. And then all you need to do is make sure that that collection of tin that it's using has enough capacity, right? And if it needs more, it'll tell you, right? Please add some more tin to this cloud, right? So it really is, I almost think the traditional on-premise box application in this new world sort of goes away. There is only 2 things. There is a public cloud and a private cloud.
So that means, so are you saying then 2 to 3 years for the private cloud to be available?
Yes.